let's look at example 8A and 8B. I'm going to first come off to the side, and I'm going to make that first quadrant with these common angles of 30, 45, and 60. So 1, 2, 3, 1, 2, 3. Again, we take the square root of each of these, but remember, we know the square root of 1 is simply 1. On the bottom is going to be a 2. And then let's go back and let's remind ourselves, what is the tangent? This is square root of 3, 1, and the tangent here is square root of 3 over 3. All right, let's get started. Where is a tangent equal to negative square root of 3? So that's a reference angle if you want to think in terms of degrees of 60 degrees or pi over 3. So where a tangent's negative, all star trig class has negative tangents in quadrant 2 and in quadrant 4. So I want to know what would be those marks. So we can see here that we have a reference angle of 60, and we can see here we have a reference angle of 60. That would be at 2 pi over 3, so x equals 2 pi over 3, and this would be at 5 pi over 3. All right, now let's look over here. Now this is going to relate back to what we just did in part B of the previous video in example 7B. Notice the difference in what we learned in the first two videos and the third and fourth is now we have a number in front. So how does this relate? Again, I'm going to bring this back as we're learning this just so we have this idea. So I'm going to do 2 revolutions. The very first revolution, I can see I already have answers of 2 pi over 3 and 5 pi over 3. But I'm not setting it equal to x, I'm setting it equal to 2x. Now when I solve for x, I could divide by 2, but even easier is to multiply by the reciprocal of 1/2. I'm going to do that on both the left and the right. So I have x equals 2 pi over 6. Well, that reduces to pi over 3. And over here I have 5 pi over 6 and 5 pi over 6. Now if you're thinking to yourself, before we even look at the second revolution, did I do that right? Again, let's make sure that we are in radians. I'm going to type in tangent of 2, and I'm going to type in parentheses pi divided by 3, and we should get an answer that is equivalent to negative radical 3. Well, what is negative radical 3? Let's check and see. And we can see they are equal, so I feel confident in these 2 answers. Now in the second revolution, I'm going to see where did I land. I landed at 2 pi over 3 and 5 pi over 3. Okay, 2 pi over 3 is right here, and 5 pi over 3 is right here. So I'm going to make these little marks right now for us. That's where I landed in one revolution. So 1, 2, 3, 4. So 4 pi over 6, 5, 6, 7, 8, 9, 10 pi over 6. Yes, it reduces down. 11, 12. Now here's my second revolution. I'm at 12 over 6. 13, 14, 15, 16. So I'm going to come off to the side, write 16 pi over 6, 17, 18, 19, 20, 21, 22, and 22 pi over 6. At this point, we really don't have to reduce them. We'll reduce them the final answer. So I'm going to take 2 pi, or excuse me, 2x, and set it equal to 16 pi over 6. And I'm going to multiply by the reciprocal of 1 over 2. And now here's where you have the opportunity, which I did not do up above. If I want to, I can reduce right now. So 2 goes into itself once, and 2 goes into 16 8 times. And then I could also reduce 6 and 8 to become 4 and 3. So 4 pi over 3, I believe, is another answer. And then my last one here will be 2x equals, and I'm going to come over here, 22 pi over 6, multiplying by the reciprocal, and I'm going to reduce it. So 1 and 11, so I have 11 pi over 6. Now let's make sure that that is correct. In the same way, I'm going to go tangent of 2 times, let's try it, 11 pi divided by 6, and that should be equal to negative square root of 3, and we can see it is. I feel confident in these 4 answers. Let's go on to example number 9. Like we saw in the previous example, I'm going to take each of these factors and I'm going to set it equal to 0. Let's do one at a time. Right away, I'm going to draw an arrow above the 3, reminding myself I need to do 3 revolutions. Okay, so how do I get started here? Well, first, I'm going to go ahead and I'm going to add 1 to the opposite side. And I'm going to ask myself, where is the cosine equal to positive 1? Cosine before sine. The cosine is equal to positive 1 right here. So we have 0 pi. And now I want to do 3 revolutions. Remember that when we saw this, it says it goes from 0 pi, and we include it all the way up to 2 pi when we're going to identify the solution. So 0 pi I will include. Okay, the next one, I'm going to do another revolution. So I'm right here. I'm going to go all the way around again. And the next time I'm going to go to 2 pi. And go all the way around again, and I go all the way up to 4 pi. I'm going to take 3 pi, or 3x, and set it equal to this. Dividing by 3. Dividing by 3. And let's check this out. So I have x equals, well, 0 pi divided by 3 is simply 0. Here I have x equals 2 pi over 3. And over here I have x equals 4 pi over 3. Okay, to show that this does work, let's plug this back in. So let's plug in 0 pi, 2 pi over 3, and 4 pi over 3. We know this should equal 0. So I'm proving to myself, or you're proving to yourself, that this does work. Here we go. We have the cosine of 3 times the quantity, 0 pi. And then I'm going to subtract 1. Make sure you use the correct parentheses. You can see we do get 0. Let's do another one. We don't need to do both. Let's go with the cosine. Let's try the bottom one. Of 3 parentheses, 4 pi, divided by 3, subtract 1, and again we get 0. Okay, let's move on to the second factor. Taking the second factor here, setting it equal to 0, and solving. First, I'm going to add the square root of 2 to the opposite side. Then I'm going to divide by 2. And remember, I want you to think of this right now as in our quadrant 1, where can we find sign values that are positive? That's going to be quadrant 1 and quadrant 2. Sign is the second number, so at pi over 4 and at 3 pi over 4. But we're looking at 2 revolutions, not 3, but 2 revolutions. So this was my first revolution, my second, and my third. I'm going to do 2 revolutions now. Now in the first revolution, I agree with pi over 4. And I agree with 3 pi over 4. Each one of those I need to set equal to 2x, and I need to solve. Dividing by 2 is the same as multiplying by 1/2. So x equals pi over 8, and here we have x equals 3 pi over 8. Neither can be reduced. Let's go on to the second revolution. And the second revolution, so one revolution, when I'm working with over 4 is 1, 2, 3, 4, 5, 6, 7, 8. So 8 pi over 4, right? I need to do my second revolution and land in these same 2 spots. So 9 pi over 4. I need to land here. 10, 11. And an 11 pi over 4. Is there another way we can do it? We simply add 8 and add 8. Okay, let's come back over here. Setting 2x equal to each one of these. Again, I'm going to multiply by 1/2, which is the same as dividing by 2. I have x equals 9 pi over 8. And over here I have x equals 11 pi over 8. Now let's grab that calculator, and again, let's prove that this works. So I'm going to come up to the very top. We have 2 sine of 2, and then in parentheses, I can try any one of these. Let's try the last one. 9 pi divided by 8. And now behind this, I'm going to subtract the square root of 2. We should get an answer of 0, and we can see we do. I can try any one. It should all equal 0. So these are my 7 solutions that make this mathematical statement true.